Black holes seem to be telling us that there's something about the surface surrounding a region. This is the first glimpse, I think, of an idea called holography. What is that? So if you think about what a hologram is, at the very simplest level, it's a piece of film, but that piece of film contains all the information to make a three-dimensional image. It's the idea that there are different descriptions of our reality. There's one description, which is that we live in this space, the three dimensions of space, and time is a thing that ticks. And Einstein told us that they're kind of mixed up, but still you have this picture of space being this, right, the thing in which we exist. There's an equivalent description for a very specific model called ADS-CFT by a physicist called Maldacena, which is a dual theory that lives purely on the boundary of the space and the space itself in the interior of this region. So it's strongly suggestive that there's a deeper theory of our experience of the world, of space and time, that does not have space and time in it. And that's one of the wonderful surprises that's really emerged from the study of black holes and the attempt to answer the very well-posed questions. I should say that the work done by Maldacena was purely mathematical. It wasn't framed in the study of black holes, although the questions ultimately seem to be intimately related. So the study of black holes seems to be strongly suggesting that these ideas of holography, holographic universe, which came from a different region of physics, from trying to understand other things, those descriptions may be valid, may be in some sense true. And it seems that we're beginning to glimpse an answer, at least in very simplified models, and that the information is stored on the boundary redundantly, which means that you can lose a bit of it and still fully specify the physics of the interior. And it does seem that that's akin to or similar to the way that we will in the future encode information in the memory of quantum computers to protect them from errors. So I'm giving you an interpretation, which, and there will be other people who have different interpretations. But it does seem that whatever this quantum theory is that underlies our reality, then there's some redundancy in the way the information is stored in that quantum theory. And it does seem that that's similar to the way that we will in the future encode information in the memory of quantum computers to protect them from errors, called a quantum error correction code. And I just emphasize, you're not meant to understand what I've just said.